Welcome to English for Professional Mechanical Engineers. My name is Yiju. In today's lesson, we'll talk about the final part of microfabrication, etching. I've divided this topic into two parts, and we will cover the first part in this video. These are the three categories of microfabrication. So far, we have covered photolithography and deposition. We will move on to the third topic, etching, and focus on the first part of it. This is the outline of this section, etching. First, I will explain the meaning of etching, and then I'll move on to the methods and machines of etching. In order to form a functional microstructure on a substrate, it's necessary to etch the thin film previously deposited. In general, there are two types of etching process, wet and dry etching. And we'll only cover wet chemical etching in this video, and we will introduce dry etching in the next video. Alright, let's get started. What is etching? Etching is used in microfabrication to chemically remove layers from the surface of a wafer during manufacturing. Let's put it in another way. Firstly, it depends on chemical reaction. In addition, we remove the part that's not wanted. Next, etching is a critical important process module, and every wafer undergoes many etching steps during it is completed. So, etching is a crucial process in microfabrication. Usually, it has to be repeated many times for an electronic component. These are two types of etching, wet etching and dry etching. Wet etching, where the material is dissolved and when it is immersed in a chemical solution. On the other hand, dry etching is used where the material is sputtered or dissolved using reactive ion or vapor phase etchant. Both etchants dissolve the material. However, one uses chemicals, while the other one uses reactive ion or vapor phase etchant. In the following, we will briefly discuss the most popular technologies for wet and dry etching. Now, let's look at wet etching first. Wet chemical etching is the simplest etching technology. All it requires is a container with a liquid solution that will dissolve the material in question. This photo shows a wet chemical etching platform. Usually, it has many sets. Each set has different chemicals for dissolving different materials. For instance, buffer hydrofluoric acid, BHF, is used commonly to etch silicon dioxide over a silicon substrate. We can simply immerse the wafer in a base of etchant to remove the part we don't want. Next, based on the shape after etching, wet etching has two results, isotropic and anisotropic types. Isotropic etching, as shown on the right side of the figure, has same etching rates in all directions, while anisotropic etching, as shown on the left side of the figure, has some slow etching crystal plane. As a result, anisotropic etching has a beautiful surface plane with a typical crystal angle, while isotropic etching would end up with a smooth circular profile, like you may see in this figure. This photo demonstrates a silicon wafer after an anisotropic wet etching. The photo was taken by an electron beam microscope. As you may be aware, it has a very identical angle in all of the etched channels. This photo shows two etched channels with a circular button, which results from an isotropic wet etching. The circular profile is owing to the fact that The etch occurs in all crystallographic directions at the same rate. The benefit is that etch rate may be very fast, many microns per minute. However, the disadvantage is that masks are undercut, as you may see in the red circle of the figure. Alright, we have pretty much covered the material for today. Let's reflect what we have learned in this video. This is the content of this topic, etching. We started by explaining the meaning of etching and learned two methods, wet chemical etching and dry wet etching. In addition, based on the results of the shapes, wet etching can be divided into isotropic and anisotropic types. Next, we will recap the main points of this video by asking two questions. Question for the definition of etching, true or false? Microfabrication can only physically remove or etch layers from the surface of wafer. True or false? Alright, the answer is false. Etching is used in microfabrication to chemically remove layers from the surface of a wafer during manufacturing. So it is to chemically remove layers, not physically. Have you got it right? Good jobs. Let's move on. Question for wet chemical etching. Here are two figures. Can you tell which one is isotropic and which one is anisotropic, A and B? Okay, the answer is B is isotropic, while A is anisotropic. Isotropic etching has the same etching rates in all directions as you see in figure B, while anisotropic etching has some slow etching crystal plane, as you may see in figure A. As a result, anisotropic etching has a beautiful surface plane with a typical crystal angle, while isotropic etching will form a smooth circular button. Here is a supplement for your reference. It's a comparison between isotropic and anisotropic etchings. Basically, isotropic is fast and applicable to a variety of materials. However, anisotropic etching is more welcoming owing to the predictable profile and better depth control. Okay, so this is the end of this section, part 1 for the introduction to micro etching. So much for today, and thank you for watching. Hope you have learned something useful from this lecture. We are going to talk about second part of micro etching in the next video. So, have a good time and see you in the next one. Goodbye.